So we've done regular electronic configuration of the neutral atom or the element, but now we're going to concentrate on ions. Those are our charged particles. And this is also going to help you see why the group number has the charge that it does. We're going to start with lithium. And lithium has electron configuration of 1s1, 1s2, 2s1. So we would just write that as lithium 1s2, 2s1. And that tells me that there's 2 electrons in the first energy level. There's 1 electron in the second energy level. So I know it has 3 total electrons. And I also know it only has 1 valence electron because it only has 1 electron in all of the 2s. So that's important information because it helps me realize that, oh, that's why group 1 is a +1, because it wants to lose that 1 extra electron so that it can be like a noble gas. So when lithium becomes its ion state of a +1, it has 1 less electron. So that means it's getting rid of this electron here. So we just rewrite that as 1s2. We got rid of that extra electron. So now when you look at it, yeah, that makes sense. It's 1s2. Who else is 1s2? Helium's also 1s2. So that means lithium, when it's in its ion state of +1, is isoelectronic. Helium, because it has those same number of electrons. It now only has 2 electrons. Did not carry over my thing. There we go. It's a little bit better. So this works for everything that we have. So let's do fluorine. Fluorine is 1s2, 2s2, 2p, 1, 2, 3, 4, 5. Let's write that down. Fluorine, 1s2, 2s2, 2p5. And what does that tell me? That tells me it has 2, 4, 9 electrons, 9 total electrons. That tells me it has 2 plus 5, 7 valence electrons, because they were both in that second energy level. Okay, now it would be a lot of trouble to take off 7 electrons. That's a lot of energy. The way to make it a noble gas when it's an anion is it wants to add some electrons. So when I become fluorine, I become a -1 because I added 1 more electron. So now my noble gas configuration, or my electron configuration, is 1s2, 2s2, 2p6. 1s2, 2s2, 2p6. Notice I was at 2p5, but I added an electron, so I'm now at 2p6, which does meet that noble gas's electronic configuration. Because when I look at neon, he has 1s2, 2s2, 2p6. They both have 10 electrons now. So they are isoelectronic to each other. So you can do this for every single ion that you have out there. And that's where those charges come into play. +1 for group 1, +2 for group 2, +3 for group 3, ±4 for group 4. And then we go the other direction. -3, -2, -1, and then 0 for those noble gases. Okay? Group 14 goes either direction because it can either gain 4 more or it can lose 4 more. It's right in the middle, so the energy, depending on what's happening, is similar. So let's see, what else could we do? So we could do calcium. And actually I'm going to do calcium's abbreviated notation. Okay, so calcium is way down here. And it has a 4s2. And who is the noble gas that we are stealing it from? It is this guy. So that is argon. Argon is 1s2, 2s2, 2p6, 3s2, 3p6. So that whole amount there, instead of me writing it, I'm just going to say borrow argons and put it right in there. And then I just have to worry about 4s2. So I know I have 2 valence electrons. I also know that calcium is a +2, which means it wants to get rid of those 2 valence electrons. So when I change it to its ion, I am just going to have argons left over. Now I can't just write argon like that. You always have to write something else after it. So you cannot go, the calcium ion's electron configuration is argon. That is not going to work. Okay, you then would have to write it all out. So calcium of a +2, 1s2, 2s2, 2p6, 3s2, 3p6.